me, that would be great. And we are going to talk about hypothesis testing and significance testing this week. And the word significance definitely is going to come up a few times in terms of when we're talking about hypothesis testing and what it all means for us. So definitely keep this in mind as we go through this PowerPoint. So first off, we do have the way that we write null hypotheses is kind of our first step that we have to discuss before we move on to really anything else. So our null hypothesis is always denoted as HO. This is basically, it's also, the text is a little weird, but you know, you've seen it probably in your text like that. And then our alternative is our H subscript A. So that's the main idea just for how you label them. And our null hypothesis is always going to have our equal sign over here, okay? There's never going to be anything else except for an equal sign for your null hypothesis. So basically, the only null hypotheses that you could ever have are going to be that P equals something for like one proportion, then for means, mu equals something. Those are really the only two options that we have for writing null hypotheses, because first of all, it always has to have the equal sign. And then also, remember, we always have to use our population parameter symbols. So remember that P is for population proportions. And then our mu is for population means. So all that's saying there is that we have to make sure that we're using these symbols when we're writing the hypotheses. And then for the alternative hypothesis, basically, since there's going to be some sort of change, it can never have, I should write that here, it can never have an equal sign. That's never going to happen over here. And we are always going to have one of these three options. So the less than, not equal to, or greater than. So basically, your alternative hypotheses can either look like this. So you can have P is less than a number, P is greater than a number, or P is not equal to a number. Or if we're talking about means, I'm just going to go over here. If we're talking about means, you can either have mu is less than something, mu is greater than something, excuse me, or mu is not equal to something. So main point here is that you want to make sure you understand that there can never be an equal sign in the alternative, and we're always going to have an equal sign here in the null hypothesis. So kind of just draw out the options that you have for, this should be a P. These are the options that you have for writing your hypotheses in terms of if you're talking about a proportion or a mean. So that's the first step in talking about hypothesis testing. We do have to write the hypotheses. And then like we just did for step one, you can see state the null and alternative hypotheses. And then our next thing we want to do is check and you want to make sure that when you're writing them, when you're writing the hypotheses, that you are checking the assumptions if there are any. And they will depend on the test, so that's kind of you know, case specific. But like we said, you know, our null hypothesis, just to reiterate, is always going to have an equal sign, and your alternative is going to have one of these signs in it. So yeah, that's just to reiterate that. And so yeah, and then our second step here, we have to calculate our test statistic. So that's just talking about the summary of the data that measures the difference between what we see and what we expect. So we have what our population is, what we're trying to figure out, and then our test statistics kind of saying from all the data that we got, this is what we found, and then we're trying to find, you know, information based upon that test statistic, which is why we do step 3, determine the p-value, and then based upon that p-value, we're going to go ahead and make a decision based on that. So p-value definition, you'll see a bunch of times the likelihood of getting our test statistic or one more extreme than that. And when I took statistics, I thought this is a very confusing concept to me. I don't know about you guys, but I definitely, when I took this class, I thought the p-value is just something hard for me to wrap my head around because it seems very arbitrary. But you want to think of it, if the definition doesn't make sense to you, which to me it didn't make sense at first, you want to draw it out and understand kind of what it is. So let's say that you have your normal curve here, and you get a test statistic that's here. So let's just call this Z as our test statistic. And then you found your p-value is going to be, so your p-values, remember it said the whatever is there or more extreme. So let's say this is a right-tailed test. So if it's right-tailed, we're going to use the greater than sign for our alternative hypothesis. So that means that the data that I'm looking for is going to be this area. So this would be our p-value technically, because it's talking about, you know, the decision based upon being here or more extreme than that. So that's the whole more extreme. It's just saying, you know, however far away it is, you know, on whatever side it is. And since this is right tail, that's why we shaded in the right tail here in terms of our test statistic. So basically, as you can see from here, starting kind of with step 2, so we calculate our test statistic. That's what we got here. Determine the p-value. That's what we get here, which I shaded in pink. And then make a decision based upon what we got here in the pink. So whatever that p-value is, which we will go a little bit more in depth to now after we made a basis of it. So once again, these are, like I said, we're going more in depth to all of them now. So our first one, you want to state that null and alternative. We won't go too far in depth to these because we've been talking about them. But remember, our null is always going to have that equal sign to it. And then the alternative is going to have either your greater than, less than, or not equal to. And the null, like it says, explanatory variable does not affect the response variable. And I always just say this as no change. And then for the alternative, the explanatory variable does affect the response variable. So this is, I just say that there is a change. So yeah, once again, these are how you state your null and alternative hypotheses. You know, just understand what they are, what the null means, what the alternative means, how to write them. And then second, we want to calculate that test statistic. Third, p-value. And this is just kind of, the more you like see the steps and read over them, the easier it'll come to you, that you won't really have to think too much about it. So just keeping that in mind. So yeah, and then so you want to determine your p-value then based upon that test statistic. And then lastly, make that decision based upon the p-value. So everything kind of goes off the last step, as you can see. So your decision is basically saying, is there an association between the two variables that you got? So remember, we're talking about, as you see up here, our explanatory variable and our response variable. So we're trying to decide if there's an association. So depending on our p-value, that's going to tell us, you know, if there's an association or not, which is why we use that p-value to make this decision here. So that's kind of an overview of hypothesis testing. Let's do some reviews, and I think that you know, hypothesis testing is best if you do reviews and, you know, review questions and work the problems out on your own to test, you know, and see if you know it. So we'll try going over these, and then if any questions come up, you know, in between, feel free to ask. But let's try this first one. So we have the null and alternative hypotheses are based on statements about what? So try this one. We have A sample, B population, C data, or D test statistics. So try this one out, and then we will review it. You can go ahead and type your answer into the chat box for me. Okay, good job, guys. Thank you for participating. So remember, when we were talking about writing our null and alternative hypotheses, I told you that basically you have to use, so for example, for our null hypotheses, you're either going to have one that says p equals whatever your value is, or mu equals whatever the value is here. Okay, and then I guess if we also talk about our alternative hypotheses, you can have p is either, so you have p is less than a value, p is greater than a value, or p is not equal to a value. And then the other option is that mu is less than a value, mu is greater than a value, or mu is not equal to a value. So if we look at this, p and mu are representing what? Are these going to be our Are these population symbols, or are these sample symbols here that I drew out and that we use in our null and alternative hypotheses? Just a follow-up question. If you don't know, that's okay. Holly's like, I'm changing my answer. But so yeah, good. So yeah, definitely these are going to be, those are our population symbols that we use. So remember, so like I said, these are population, and then I mean, just to compare to when we're talking about samples, that's going to be our p hat and then our x bar. So, but we're not talking about them. That's not how we write our null and alternative. So that's why it wouldn't be A, and C and D just don't make sense because our null and alternative are always based upon the population. So just think about hypothesis testing, logically, that, we can't get a lot of data from we can't get the data from the population as the entire thing. So we're going to take a bunch of samples out. But in reality, we're still trying to find out information about our population in the end. That's the main goal, obviously. We don't really care about this specific sample. If you're looking for information about population and you have to take samples from you have to take a bunch of samples at first, in the end you're trying to make an inference about that population, which is why you want to make sure that we're talking about our null and alternative in terms of our population parameters here, because in the end these are the ones we're making decisions off of. So we're either basically rejecting or failing to reject these, and it's in terms of our population, which is why we use the population symbols there. So our answer is B. So good job, guys. This is a tricky chapter, so I hope this is making some sense. Okay, so which of the following is one of the steps found with hypothesis significance tests? So we have A, state the null and alternative hypotheses, B, calculate the test statistic, C, obtain the p-value, D, state a decision and a conclusion, or E, all of the above. So go ahead and try this one out and let me know what you think. Okay, good job. Absolutely. So our answer here is going to be E, because really if we go through all of these are the 4 steps that we take. So our first step is going to be A. So we're going to state our null and alternative hypotheses, and then letter B is going to be our second step. So calculate that test statistic. C is step 3, obtain the p-value, and then our step 4 is D, state a decision and a conclusion, based off of your p-value. So that's from step 3. So our answer is E, all of the above, because these are all steps within our hypothesis testing procedure. They just happen to be in order too. So that's just making sure you understand the different steps we take and making sure you don't skip any of them. So good job. All right. We have 2 more, I think. So the maker of M&M's candy says that the proportion of all plain M&Ms that are blue is P equals 0.24, 24%. George thinks he has purchased M&Ms from a bad batch where the proportion of M&Ms that are blue is less than 0.24 and gathers a sample for the purpose of proving this. For Kyle, what is the alternative hypothesis? So try to write the alternative hypothesis and pick one of these options here, and then we will go over it together. Okay, good. Thank you so much for participating, guys. You guys are doing great. So let's look into this one. So we have, basically they're saying that they think the proportion of them is 24, like 0.24. So I'll show you this. So basically we can write our null hypothesis already that P is 0.24 because basically it's saying that this is what we have. Like M&M's candy is saying basically the proportion of all of the candy is that's blue is going to be 0.24. But George thinks that his is different, so he's saying that he thinks that it's less than 0.24. So in this case, our answer is going to be B. Yeah, great. Because then we have P is less than 0.24 in this case. A would be if he thought that it was greater than 0.24, and then C is just not correct because you don't have an equal sign in your alternative hypothesis, and then D would be if you thought it was like not 0.24 basically is how it would be written in the question, you know, that, or that he's saying that it's different from 0.24. Then that's when you would use the not equals to, because it's basically saying he's not specifically saying if it's lower or higher, but he's saying that it's definitely not 0.24. That's when you use that. But in this case, he said that it's less than 0.24, so that's why we use B for less than. So good job. All right. All right, let's do one more. So we have in testing whether a new treatment for relief from arthritis pain works better than a similar dosage of aspirin. A researcher calculates the test statistic equal to 2.8, and the p-value is 0.003. Which of the following is the correct interpretation of the p-value? So started you off with the sentence here basically. So the likelihood of obtaining the test statistic of 2.8 or, and then read through these 4 options to try to finish that sentence, and then we will go over it. So this is about interpreting our p-value. So we'll try this one out and let me know what you think. Okay, awesome job. Yeah, so this is a tough one for sure. So our answer is C. So good job. Let's go over this one. Okay. So remember, by definition of our p-value, we have that, because this is saying what is the interpretation. So this is kind of like our definition. So the likelihood of obtaining the test statistic, and in this case it's specifically 2.8, or, and then we always have any value more extreme. So remember I was showing you, you know, if we're talking about, let's say that we have an alternative hypothesis that involves it being less than, then we'll have our test statistic, and then anything more extreme and it's less than, so that's going to be more extreme would be to the left. And then like we talked about earlier, if we have an alternative hypothesis that's talking about greater than, so it's going to be anything more extreme, which is going to be to the right, greater than, and then less than is negative there. So that's why we have, or any value more extreme if in fact, and then remember we always make the assumption that our null hypothesis is true. This is always the assumption that we make. And then in this case, since we're doing this, so any value more extreme if in fact the null hypothesis is true. So that's why it wouldn't be A or D, first of all, because it's talking about less extreme, which is not something you'll ever really see in a definition of a p-value. So between B and C, we know that C is correct because it's talking about the null hypothesis being true, because we always make that assumption starting our our problems, and then is 0.003. Because remember, p-value is still technically a probability, so that's why we say the likelihood of obtaining the test statistic. So yeah, so that's why our answer would be C there. So great job. Alrighty, so that's all we got for tonight. So our next review won't be for another 2 weeks, sad, but we're not going to be, you know, reviewing on Thanksgiving, unfortunately. I know you guys are bummed about that one, but yeah, so if you haven't, I think everyone gave me their Penn State email, so thank you for that. Let me know if you have any other questions. If not, have a great Thanksgiving and a great holiday, and sleep some, and maybe don't think about stat for a second, but then come right back thinking about it because the final's coming up. But, but yeah, let me know if you have any more questions. If not, you guys are good to go for the night.